Might as well be a Monday.
Neither do we.
I know, right? Okay, so local extrema and concavity. So first derivative test, find it. Second derivative test, determine concavity of a function, find inflection points, and second derivative test. Okay, all that makes sense?
Yep.
I'll abbreviate it here shortly, and you'll be like, oh, damn, that's easy. Okay, now, remember those flashcards I gave you?
Yeah.
Yeah, anyone actually like cut those out and put them together yet?
I still have the old ones from last
Okay, yeah, if you got them, it's good. Now, some of these things are very helpful. Having these on your flashcards, they're great. Having your ln rules, the derivatives, ln's, and logs, those are amazing. Having the arc tangent, arc secant, all the derivatives of those are good. Flashcards, test yourself because those keep coming back. Okay, those are going to end up on this next test, I think, if I remember. Okay, because everything is coming back around. So, like, I think it's like the last 4 questions on the multiple choice of every test is actually from previous units. So, I don't know if you guys notice that. Okay, anyway, but still. Okay, so all this, first derivative test. So, if the derivative is greater than 0, then therefore it's going to be increasing. And it goes, crap. This font's weird. Yeah, okay. So from A of X to C of blah, blah, local maximum. Okay, so now, think about this. Okay, so, no, seriously, like, my dyslexia is, like, so got me on today. All right, you ready? So, if the slope is going up, then all of a sudden on the other side of some number, the slope starts going down. Therefore, that is a maximum, right?
Yes, sir.
Okay, so the slope, remember the first derivative, right? Okay, very good. So if the slope is going down, okay, if it's a negative slope, then it changes to a positive slope. Therefore, that point where it changes would be a
minimum.
Thank you, very good. That's basically it. All right. Okay, if it has no sign change, then it is neither local minimum or maximum. Okay, so let's take a look right here. Okay, critical numbers, we have increasing here, bam, decreasing to here, bam, and increasing, right? So positive slope, negative slope, and a positive slope again, right? Okay, so in between a positive and negative, you have a max. In between a negative and a positive, you have a min. There we go. All right, find the local extrema right here. So first thing you have to do is take the derivative. So f prime of x is
4x cubed
minus
12x squared.
Woo! Look at that, man.
I don't know why I said anything.
All right, so what do we got to do? Say f that. F that. So if I f that, I end up with what?
4x minus 12. Wait.
4.
No, okay, well we can get rid of
X
minus 12
squared, right? Parentheses.
Yeah. Yes.
X minus
3.
Very good. And that's going to be set equal to 0. Okay. So this is going to give me my critical points, right? So now think about critical points. I need to talk about domains too, right? Domains. Is there any place where it's going to be undefined or undifferentiable? Say no. No, there's not. Okay, so we're good, right? All right, so zero product rule. So this is going to give me 4x squared and 0 equals x minus 3. So therefore, x here is, say, plus or minus 0.
Plus or minus 0.
As soon as you can figure it out, yeah.
Plus or minus 0. Plus or minus.
This thing goobarred on me this morning too.
Having a seizure. I think it's good now.
I gotta wait till it decides it wants to work again.
This is all happening while recording.
I know, right? This thing is getting worse too. They told me that they could actually give me another one. Yeah, this one's actually been broken since the day they installed it. So it's been doing this the whole time. Anyway, all right, so let's try that equal sign now. Hey! Plus or minus 0, right?
Wait, you're from the plus or minus.
Do you know why it would be plus or minus 0?
Because it's squared.
Yeah, so you get a plus or minus out of it, right? Okay, good. All right. All right. Okay, so this is x is going to be 3. Woo! Critical points, right?
That's a jump.
Critical points. Those are points that I'm going to have mins and maxes, right? Mins and maxes. So, what could I do to figure out mins and maxes here? Just using this first derivative test. Plug in points. Now, I'm plugging in points to what? To my first derivative. That's why it's called a first derivative test.
We're checking the slope.
Yes. Okay, so let's plug in -1. So if I plug in -1, outside is going to be a positive, right?
Yeah.
So that's going to be a positive, but inside here is going to be a positive and a negative gives me.
Negative.
So this is a negative right here, right? So a number between 0 and 3. 2. She wants 2. Okay.
1.
So 2 squared. That's positive on the outside, right?
Yeah.
Okay, so this is going to give me a negative, right?
Yes.
So, hey, look, negative again.
Whoa.
Whoa.
Whoa. Like, whoa. Anyway, all right. Okay, give me 4.
4.
Okay, good. 4.
Yeah.
Okay, positive, right? So it'd be positive here, and it would be positive here. So that means on that side it's going to be positive. All right, there we go. Okay, so we could actually do more stuff once we get to the second derivative test. So first derivative test, that's basically all you're getting. So we know that it's increasing from where to where? From 3 to infinity. Okay, and I know it's decreasing from
3 to negative. Well,
from negative infinity to
3. Or is
Okay.
it 0?
to so 0. Is it at 0? Is that still decreasing?
No, because the slope would be 0.
Slope is 0, so it's not decreasing at that. So it would be at 0, goes to 0, and then again from 0 to 3, right? Okay. All right. So good. Bam. You know what? Yeah. You know what? We're good. No, because I want to get to the second derivative test. We don't need to practice it the same thing again, right? Okay, function is continuous for all real numbers. The graph of f prime is below. Ooh, this is the graph of the derivative. Dun-dun, dun-dun. All right, so what does that tell me about this point right here?
That the slope is
That's a critical.
Yeah, that's critical.
Okay, so the slope here is 0, right?
Yeah.
The slope is 0. So that's going to be a critical. That's going to be either a min or max. But now all these numbers from here to here. So all these numbers from here to here are, they're negative. So all of these are negative slopes, right?
Yes.
All these right here are negative slopes. Very good. Okay, so now up to my critical point right there. Right? And because, remember, we're talking about the slopes. All these are referring to slopes. This is not the function. This is just the values of my slopes right here. So now, that's critical point at 0 here, right? So now, from here to here, that's below the line, right?
Yeah.
So all those are negative also, aren't they? So all that's negative. So we're saying that this is negative up to a critical point, and then, ooh, hey, look again. That is also a negative down here, isn't it? So it's negative, and it's negative right here. Right? Here is another critical point here at 2, right? Okay, critical point, that's where my derivative is equal to 0, isn't it? So that is a critical point. So what does it tell me from this side right here? Those are positive, so the slope is positive from this point on. Okay, does that make sense? It's pretty simple, right? Okay, but you just got to wrap your head around that we're only talking about slopes here. This is the slopes, it's not the function. Okay, it's just slopes. All right, so determine critical numbers of f. Critical numbers would be 0 and 2. Where is f increasing? From 2 to infinity. Where is f decreasing? from negative infinity to 0 and from 0 to 2. Okay, at what numbers x does f have a local minimum?
At 2.
Okay, think about it. Local minimum, what has to happen? Negative to positive. So the only place is only going to be 2, right?
Yeah.
Okay, so I'm just making sure you guys understand. If it changes from negative to positive, right, so it's going down, then all of a sudden it means it's going up. So slope's positive on this side, slope's negative on this side. So that means that's a local minimum. Okay, does it? At what numbers does it have a local maximum? Does it ever change from positive to negative? No, so it does not. Distance of an object from origin time t given by the function s equals f of t. Velocity v of t is the distance, so it's distance over time, right? So it's the change in, so it's the ds dt, so it's the derivative of this, okay, in terms of time. So if v is greater than 0, okay, v is greater than 0, the distance s from the origin is increasing with time, and the object is moving to the right. We always think about in functions because we read our Cartesian graph from left to right, don't we? Mm-hmm. Okay, so now, same thing goes right here. So if v, okay, the velocity is less than 0, the distance at s, the origin, is decreasing with time, and the object is moving to the left. So it's possible for there, so if you think about it, for me going from here to Douche Bros, okay, I would be a positive velocity going there, and I'd have a negative velocity coming back, right? Okay, good. All right, so if the velocity is equal to 0, then the object is at rest. So that means that I'm at Douche Bros waiting for my latte, okay, with almond milk, okay, sugar-free vanilla creamer, just so you guys know, okay. All right, sugar-free, please, okay, all right. All right, so object moves along a horizontal line so that distance s from the origin at time is greater than or equal to 0 in seconds, given by s is equal to t to the third minus 9t squared plus 15t plus 3. Determine the intervals where the distance is increasing. Okay, so
Easy.
For the velocity.
Katie,
So we gotta derive it.
yeah, let's do that. Okay, so the derivative of s would, I could just say that's v, right?
Yeah.
Okay, good. So I'm going to say v. So v of t, right? Ah, dang it. V of t. V. Oh, crap. Brain. V of t is equal to 3t squared minus 18t plus 15, blah. Right?
Yeah.
Okay, good. All right, so now what do I have to do with that Rothar? Set it equals 0. Set it equals 0. So if I set it equals 0, can I F any of that? Say yes.
Yeah.
Okay, you can F out of what? All right, so V of t is equal to 3 quantity. So that's going to change this up, right? So it's going to be t squared minus 6t plus 5, right? So what are my factors going to be? -5 and -1, right? Okay. Did anyone have trouble looking and seeing that? Anyone? There's a little trick to it, so that's why I want to show you guys. Does anyone need the trick?
No.
No? Yes? Maybe? Possibly? Okay. But I want to show the trick. I feel like it.
No.
Okay, just show the trick, yeah.
Okay, I'll show you the trick. Good. See? That, yeah. Anyway. All right, see how this piece is positive right here?
Yeah.
If that's positive, that means the signs have to be the same. Okay? And if the signs are the same, this thing right here tells me what type of signs I'm going to have. So if this is positive, that means both these are the same, and this is negative. That means that both of them are negative. If this was positive, that means both of them would be positive. If this right here would ever be negative, that means the signs have to be different. Okay, to get a negative, you have to have a positive and negative, right? And for this piece right here, it's whichever is the largest number is going to get the sign. So if I had a negative here and a negative here, I have a positive and a negative, but the negative one is bigger. Okay, if I have a negative here and a positive here, that means it's a positive and a negative, but the positive one would be bigger to get the positive sign there. Just a trick. Okay, sorry. Anyway. So we said t what? Minus 5
Yeah.
and t minus 1. All right, so I had those things right there, right? So, okay, so we have that factored. So my critical points are where and where and where? Critical points are where?
At 5 and 1. T equals 5, T equals 1.
Okay, t equals 5, t equals 1. So there's my critical points. And so let's take a look at, now let's, if I were to number line that, I'm going to start 0, 1, and I'm going to start over here, 5, over here. All right, so given that much information, so if I were to plug in 0.5 to see what my slope is going to be from 0 to 1. So I'm going to plug it in here. I like plugging it into the factored, so it helps me with the signs. So 0.5, that means that would be a negative, right? Yeah. 0.5, this would also be a negative, right? So two negatives make a positive. Okay, so now let's do it again. So from 1 to 5, I'm going to plug in 3. Okay, so I'm going to plug in 3. So that would be, this right here would be a negative, and this one right here would be a positive, right? Positive, negative, so that makes that a negative.
Yep.
Let's go 4. Oh, I'm sorry, 6. Sorry, 6. So if I do 6, this would be a positive and a positive. Positive, positive makes a positive. Thank you very much. So, what do we know?
There's a maximum at 1 and a minimum at 5.
Okay, so maximum at 1, minimum at 5. Okay, determine intervals where the distance is increasing. Distance would be increasing
0 to 1.
0 to 1 and from
5 to positive infinity.
very good. Okay, so determine where distance is decreasing from 1 to 5. When does the object reverse direction?
What?
At 1, right? At 1, because my critical value here says that it's now decreasing here, right? So it's going to change direction from here to here. Okay? So it's changing direction there, right? And, okay, so right here it's going, so think about this. I'm going to Douche Bros again, okay? So I'm heading to Douche Bros, but then there's that, like, that magic card shop right over here on the corner. And so I'm like, hey, I head over there, but then I'm like, oh, yo, they got a sale. So I turn back around and I head over there, but I'm not heading all the way back, am I? No, I'm not going all the way back. But then I'm like, hey, yo, you got this, Planeswalker card? I'm like, yeah, I got that. And then they're like, okay. So anyway, so at 5, I change direction and head back over to Douche Bros, right?
Right.
Are you laughing because you know what I'm talking about?
Yeah.
Okay. I know, right? Okay, so yes, changing direction. So yes, I came back to go to the magic card shop, and then I got my card, then I head back and it's on my way over to Douche Bros. All right, so draw a figure that illustrates motion of the object. Kind of did here. All right, what is the velocity of the object increasing and decreasing? So velocity increasing from here to here.
Yes.
Okay, and here to here, decreasing there to there. All right, when is the object? Draw a figure that illustrates the velocity of the object. There we go. Okay. All right, I want to try and get to the other problems. Okay, concavity. So this is what I've really been looking for. So concave up and concave down. So now think about this. No, because I always screw this up. So no, listen, I always look. I'm looking. No, bro, seriously, you guys are gonna do this whenever you have this freaking problem. The same thing I'm doing right now. Okay, you're looking up, and so you're like this, and so that means it's so if it's up, if it's going up, it's positive. Yeah, it's positive. It's going up, so that means it's a minimum.
Yes.
Okay. That's by concavity. See? Anyway, all right.
Okay.
I hate you all. All right, so concave up, concave down, grapholize. Okay, so okay, here's the trick for this. The test for concavity. That's what I was just doing right now, like a special person. Okay, so now check it like this. You take your hand. So this would be a minimum, right? This would be a minimum, but which way is it opening? It's opening up, so that means that's going to be up is positive, down is
Negative.
So if it's opening down, what type of arc is that? That would be a maximum, right? That's a maximum. Yes, I am. Yeah, I am south side concavity here. Okay,
careful.
Okay, so all right, you guys. So using your hands on this, this is actually is this helpful for this?
Yeah.
Okay, so if it's like this, it's concave down, so it's looking down, so that's a negative. Okay, if it's concave up, that is my minimum, and it's positive because it's opening up. That's what we're saying here.
During the eighth
I don't think the people in
The viewers are gonna have a hard time here.
They're gonna hear nonsense. They're gonna be like, what?
Make it you with your
Here's
hand,
oh crap. Okay,
Trace
so
it. There you go, trace it.
all right, so it's gonna be
That's a hand.
Yeah, they don't know
Yeah,
it's
use
a
your
hat.
other
They don't-
Just like a hand.
It's a dog.
okay, so that's your face. All right, so this is my hand. It's my weird fingers. Anyway, all right, so this right here
Oh,
would be my min, and it's opening up. My min is opening up. So the concavity, so this means that it's going to be, so F double prime would be greater than 0.
Because it's opening up, it's going, positive up.
Yep, see right here. Opening up is positive. So same thing for my gang side going down.
Trace another one, Mr.
Oh, bro.
Wait, can
Use
you like?
use the other
Hey,
hand.
Can you like?
I'll
Use
draw
your
it.
Can't-
yeah, there,
you read?
there
Have
we
somebody help you,
go.
That's that's fine.
Oh,
Uh-oh.
He said, uh-oh.
Sense you.
See, that one's okay.
There you go. That was
there we
way
go. That
much
looks
better.
way better.
Anyway, all right. So
Just a little bit of detail.
Hey.
I know he did.
Okay.
All the way up to it.
anyway, all right. So right here, so by looking at this, this would be a max, right?
Right.
So that would be a maximum, and it is going down. So that means that F double prime is going to be less than 0. Okay, so it's concave down, right?
Right.
It's concave down. So it's opening down. So this is going to be a negative, and this would be positive. Make sense? Okay, good. So listen, yeah, even on the AP exam, I'm going to see you people be like,
You'll see us look up for like 2 minutes.
I know, right?
And then pop out the.
No, yeah, a couple of the things. You know, I'll watch you doing that, but you know, you're like praying, please, Lord, help me.
Yeah, you make confusing with praying.
I know you gave me 2.2 on the 2 plus 2 on the calculator portion, but some ridiculous on the non-calculator. All right, okay, show that this is concave up on its domain. No, it's exponential, so it's
it's
Anyway,
always-
yeah. So I want to actually do the. Okay, here we go. All right. I'm trying not to waste the time because I want you guys to get this. All right, so finding the local extrema of the function. So right here, let's go through and find the derivative, then we'll go on to the second derivative test. All right, so first derivative. So f prime of x is 3x squared minus 12x plus 9. You know, f that again, so it's going to be 3 parentheses. Okay, so that's going to give me a, what's that? That's going to be x squared minus 4x plus 3, right?
Yes.
So it's going to be negative 1, negative 3. So x minus 1, x minus 3, right there. So because of that, I know I'm going to have my critical points where?
X equals 180.
Okay, so it's x equals 1 and x equals 3. So my number line from, oh, come on, don't do this again. All right, 1 and I have 3 right here. So I could test points in between here, right? I could test points or determine where the is concave up and concave down. So let's do the second derivative on this now. So if I do the second derivative, okay, so it'd be f double prime of x would be 6x minus 12. Set that equal to 0, right?
Yeah.
Set it equal to 0, so it's going to be 0 equals 6 quantity x minus 2. So x is 2. Okay, so now what that's going to tell me, so the second derivative test is going to tell me that from here, when I set the second derivative, this is actually part of the next slide. The second derivative equal to 0, that's going to be the change in the concavity. Okay, so when you're looking at the thing, it's going to change in concavity. That means it's changing from a concave up to a concave down. Okay, it works very well with like a sine wave. So if we're looking at a sine wave, right here, graph a sine wave. So on a sine wave, wow, that is just creeping down. We know that at this point right here, it's changing concavity from a concave down to a concave up, right?
Yeah.
And that's what we just found with the second derivative. So we have that. So we have right here, that's basically what's happening. My concavity is changing, but if you notice, the slope is not changing yet. The slope is still negative. From here to here, the slope is still negative, right? The slope is still negative. So given this, but it's going to change in concavity. So now at this point, it's going to be, so this is decreasing at an increasing rate. And from this point right here, that's going to change concavity. So it's still decreasing, but it's at a decreasing rate. So decreasing at an increasing rate, and here changes to decreasing at a decreasing rate. And once it gets to 0, then it's going to change and go back up, right?
Yeah.
Okay. Did I confuse you on that, or, huh?
No, like I understood. It's
Yeah,
just
yeah.
kind of funny to listen to it. Decreasing on the increasing, now it's decreasing on the decrease.
Okay, okay, me walking back over to Douche Bros. Okay, you know what? I'm kind of a slow person. I'm going to go at a constant rate, but then they're like, hey, it's the first day of the month and we only have like 10 stickers left. I might like increase the rate to actually try and get one of those stickers that they have. They're like, hey, yo, that sticker's awesome, right? And so I would be increasing at an increasing rate, right?
Right, because you're already heading over there, now you're picking up your pace.
Yes, so I'm increasing at an increasing rate, right?
Yes, yeah.
Okay,
Now I
so,
get there.
but then, you know, someone says, they call out, they're like, okay, we're all out of stickers. So at that point, I'm going to be,
Turn around.
no, not turn around. I still got to get my caffeine fix. So I'm going to be increasing at a decreasing rate because I'm going to slow back down, right?
Yeah, you're
Right.
slowing down. So, okay.
Yeah, I'm going to slow down, but I'm still heading over there, right? Because I got to get my caffeine fix. Does that make sense?
Yeah.
So if I put it in an analogy of me going to get coffee, you guys get it, right?
Yeah,
Okay.
actually.
Okay, so concave up, concave down. So let's take a look at this. So this is going to be my change in concavity, right?
Right.
Change in concavity. So that's the only place where I have a change in concavity. So let's test it on the left side of that. So at 2, test it on the left side of that. So like 1.5. 1.5. Let's check out what it is in my second derivative at 1.5. So at 1.5, that's going to give me a negative times a positive. So this is a negative. Okay, so this is a negative for my second derivative test, right? So it's a negative on my second derivative test. Now let's check it on the other side. So 2.5. 2.5, that's going to be a positive, isn't it?
Yes.
Okay, it's a positive and positive, so this is a positive. Okay, so what does that tell me about my concavity? So from 2 on, okay, to my critical point is going to be, so it's positive, right? So that's concave up. So therefore that's going to be, at 3, it's going to be a
Min. Or is it a max?
At 3?
At 3 or 2?
Wait, or 2?
Yeah.
3. I'm talking about 3 right now.
What? Yeah.
I'm just talking about 3. Okay, from 2 to 3, it's positive, isn't it? The second derivative is positive. So that means that it's positive, so from there to there, it's going to be concave up, right?
Great.
So what does that mean for 3?
Maybe a max. It's a max. I thought it was a min because if it's a positive.
It's a min. Very
Yeah.
good.
Hello?
So, okay, that's going to be a min. Remember, we're only talking about the second derivative now. We're not talking about the first derivative no more.
Right.
So the second derivative is concave up here, right? So therefore 3, my critical point, has to be a minimum. Minimum, all right? Same thing goes from right here. So on from 1 to 2, So now I know that concavity is negative, isn't it?
Yes.
So
Yeah.
negative,
You know this.
right?
Yeah.
So negative. 1 is a critical point, isn't it? Okay, so the concavity this way, so if it's negative, it's opening down, right? So that would make 1 be a
Maximum.
maximum. Does that make sense?
Yeah.
Okay, do you guys want to graph this whole thing?
Graphing it right now.
Okay, so that's, let me see. X minus 1 and X minus 3. All right. Documents. Bam. All right, so what was the function in the first place? X to the
Third power
third.
minus 6x squared plus 9x plus 30.
There you go. All right, so let's do a zoom fit. Menu, window zoom, fit. There we go. Ooh, excellent. Okay. So right here, what are my intervals I'm going to look at? So let's do a window.
What?
That was so
Wait, what?
scary.
No,
Is that a threat?
no, he.
Yeah, your key and it just like didn't even close the door all the way.
No, I'm waiting. He's got something for me, so you guys be quiet. All right, so what are my numbers?
Gee, look at that white hand.
Let's say 0. And how far are we going for the X max?
I think it was 3.
It was 3, so let's go to 4. Okay. There we go.
Nice.
That zoom fit messed me up though. Let me see. Window right here. This. Oh wow, that's why. Let's go just -4, and let's go 4. Okay. So
Nice.
there we go.
Now you can't.
Perfect. I love it.
Oh.
Doc B.
Macho.
Just
Damn,
reset it.
control.
Doc
Yeah.
B.
Just do like -10 to 10 though. Maybe that.
-10 to 10.
Yeah, maybe that. I don't know. No, because it's a
Well,
plus
that's
30. There's a. So it's
Oh,
gonna be
you're
up
right,
high.
you're right.
It's gonna be up high. So yeah.
So do like
So no, the Wyman should be like.
do 100 and because it's obviously increasing.
No, just do 50 then.
Yeah, keep the X.
Ooh,
-0.
yes. Oh, yeah.
You change
I know it's
the
kind of
Y
like that
up.
plus or minus that I had. All right, so we said negative what? -40 and 40.
Yeah, so.
There's not much downstairs.
Yeah, I was gonna
There we
say,
go.
right
Okay.
down there.
So here it is. So here's my 1, right? So we said 1 had to be maximum,
Yeah.
and we said that 3 had to be a.
Minimum.
Yep. See, that's what we have here.
Ooh.
Not bad, right? Okay. So I'm just trying to make sure inflection points. We just talked about that. You guys got the test. Finding them, second derivative. We did the hand thing. Oh crap! Yeah, I got too many. So
Wow, we did them all.
we did most of them, but I'll start this one tomorrow. Okay? All right, so don't forget, like, subscribe.